Hello everyone. In this session, let us discuss the topic trigonometry, which is one of the branches of geometry. We knew very well mathematics is divided into various branches like number system or number theory, statistics, algebra, geometry. Like that, there are various branches in mathematics. In that, geometry is one of the branch. In that geometry, trigonometry is a subtopic. That trigonometry introduction let us discuss in this session. Okay. Before talking about the trigonometry, let's do a small activity. Then we can understand exactly about the trigonometry. In this video, we are not going in detail about the trigonometry because there are many introductions to the trigonometry. I'm going to some extent in the grade 10 point of view introduction of trigonometry. Okay. Yeah. Yeah. Let's do that activity first. Imagine we have three persons: Rohit Sharma, Virat Kohli, Hardik Pandya. These are the three persons we have. From these three persons, we have to choose one captain and one vice captain. So what are the possibilities we have and how many are there? Three persons, Rohit Sharma, Virat Kohli, Hardik Pandya. From these three, we have to choose one captain, one vice captain. You know very well, captain doesn't mean vice captain doesn't mean captain. They both are different. I hope you know that. Right. So let us see what are the possibilities we have. Maybe Rohit Sharma is the captain, Hardik Pandya is the vice captain, or Hardik Pandya is the captain, Rohit Sharma is the vice captain, or Virat Kohli is the captain, Rohit Sharma vice captain, or Rohit Sharma is the captain, Virat Kohli is the vice captain, or still what we have? Forward done. Still we can say Hardik Pandya is the captain, Virat Kohli is the vice captain. Virat Kohli is the captain, Hardik Pandya is the vice captain. Do we have any other possibilities other than these six? No. These are the only possibilities we have. Three things, arranging three things in a particular way. We are choosing two out of three in a particular way we are arranging. Actually, permutations point of view, if you see permutations and combinations point of view, choosing three out of three, choosing two. 3p2 we call permutations, which is higher grade, which is equal to 6 3p2. Okay. As it is very simple, I just made it as an activity and I discussed. This is very much needed now to discuss the basic information of the trigonometry. Okay. So just let us keep this aside. Now, let's talk about the trigonometry. Trigonometry, three angles measurement. So the topic which deals with the three angles measurement is called trigonometry. So in this trigonometry, we'll discuss about angles. We knew well, three angles containing one means where it will be triangle. So triangle we choose. Basically, we choose right angle triangle. Later on, we can apply trigonometry to any kind of triangle because mathematicians, they introduced the topic trigonometry by considering right angle triangle first. Later on, they spreaded it. They developed the trigonometry concept even to any kind of triangle. Could be acute angle triangle, obtuse angle triangle, equilateral triangle, isosceles triangle, scalene triangle. Even there, we can use trigonometry in a higher grades. But now, grade 10 point of view, if you see, we can use it only for right angle triangle. Okay. So let's take one right angle triangle. In this right angle triangle, I'm choosing letters for our convenience. A, B, C is a right angle triangle where angle B is equal to 90. Just I consider like that. We can choose any letters. Just for our convenience, I took ABC where angle B is 90. Okay. Now, I told you trigonometry is the discussion of triangle, especially angles of a triangle. Here, if you see, it shows the relation between angle and the sides of a triangle. How many sides are there in this triangle? There are three sides: AB, BC, AC. Benefit of right angle triangle is in these three sides, we knew very clearly about one side, which is AC, that is the greatest of all because that is the hypotenuse. Hypotenuse means longest side of a triangle, right? When compared to AB and BC, we are very much sure, damn sure, AC is the longest side. That is the benefit of a right angle triangle. One angle is 110% 90 degrees. One side is definitely greater than the other two sides. That clarity we have if it is a right angle triangle. Now, let's find the ratio. Let's find the relation of any two sides of this triangle here. Out of three sides, let us pick the two sides and let's find the ratio of this. Okay. Three sides are there. We have to pick any two sides and we have to find the ratio of it. How many possibilities are there for us? For that only, I gave this activity. This Rohit Sharma, Virat Kohli, Hardik Pandya. Three persons, we picked two. And there is a particular arrangement. Here also the same. Three sides are there, we have to pick two sides. And there is a particular arrangement. We are comparing AB with BC is different, BC with AB is different. In ratio, you know very well, 1:2 is not at all equal to 2:1. So order also important. Then tell me how many ratios are possible there. Out of three picking two, correct. Six are possible, right? Let's write those all information. Before that, let us clear this information of Rohit Sharma, Virat Kohli and Hardik Pandya. So if you observe, we can write AB, means we can compare AB and AC, which we can write it as AB by AC. In division form, if we write ratio. Okay. At the same time, we can write even BC AC comparison also, BC by AC. Ratio of BC and AC, BC by AC. And the other possibility, AB by BC. Three are possible. Is these three only possible? No. AB by AC, reciprocal, AC by AB. BC by AC reciprocal, AC by BC. Because we knew very well, as I told you, 1:2 is not at all equal to 2:1. So both can be considered here. And AB by BC we done. If you reciprocate, BC by AB will come. These are the six possible ratios we can write from the set of three sides of a triangle. Right. Mathematicians gave for these six ratios some six different names for the convenience to use again and again. Because here A, B, A, C, those are all considered by me. If you consider PQR, you'll get PQ, QR, PR as the sides. Suppose if some other person considered DEF as a triangle, DE, EF, DF sides are there. So their ratios are different. But consideration is same. Right. So universally, they gave some names based on some particular conditions. How they gave the names? They considered that, suppose, imagine here there is an angle theta, some angle theta. Then to this theta, what is the opposite side? Opposite side in the sense, the side which is nowhere connected to the angle formed theta. Theta is formed because of the sides BC and AC. So apart from BC and AC, whatever the side is there, that is the opposite side to the theta. So here AB is the opposite side. Opposite side is AB. And what is the hypotenuse? Hypotenuse is fixed. AC is the hypotenuse in this picture. So that is hypotenuse. The ratio of opposite side to the hypotenuse, they named as sine theta. Mathematicians gave that as sine theta. Okay. And BC by AC. If you observe, BC is adjacent side to the theta. Hypotenuse is hypotenuse only. That won't change. This AB and BC, if you observe, according to the position of theta, AB is the opposite side, BC is the adjacent side. The side which involved in forming theta is adjacent side. You may say that AC is also adjacent. Yes, I agree. AC is also adjacent side. But that is already named as hypotenuse. That is completely different. So when we are talking about adjacent side, we have to talk only about BC. So BC is the adjacent side. AC is the hypotenuse. This ratio of adjacent side to the hypotenuse, they named as cos theta. Okay. Whereas this AB by BC or AB over BC, if you see, AB is the opposite side to the theta, BC is the adjacent side to the theta. This they named as tan theta. These are namings. Names basically they'll collect from the some books or the situations, their terms, what they use at that year, at that moment, at that year, it is given. Okay. When it comes to AC by AB, AC is hypotenuse, we know well, and AB is the opposite side to the theta. This they named as cosecant theta. Okay. And this AC by BC, if you observe, AC is the hypotenuse, whereas ABC is the adjacent side. This they named as secant theta. And when it comes to BC and AB, BC is adjacent side, AB is the opposite side. This they named as cot theta. So 6 ratios were given by mathematicians. These 6 ratios based on the picture given. So according to my picture, we got this. Okay. Here it is AC and this is A. Okay. Right. Okay. These are the 6 trigonometric ratios. We call them as 6 trigonometric ratios. Remember, here we shouldn't uh, remember the AB, BC, AC like that because that AB, BC, AC, those are according to the triangle ABC. We have to remember that opposite side over hypotenuse is sine theta, adjacent side over hypotenuse is cos theta, opposite side by adjacent side of the theta is equal to tan theta. Like that, we have to remember. Okay, don't remember like AB, AC condition. Okay. So just for a second, have a look of that full 6 trigonometric ratios are there. Those 6 trigonometric ratios also based on the position of theta, that opposite hypotenuse will come. But the first one, sin theta is equal to O by H, fixed. Cos theta is equal to A by H, fixed. Tan theta is equal to O by A, fixed. Like that, cosecant theta is equal to H by O, fixed. Mean hypotenuse by opposite side. Similarly, secant theta, similarly, cot theta. Okay, clear? Right. Now, let us see some other triangle with some other values so that we'll understand very clearly. Now, D, E, F. Angle D is equal to 90, for example. Then imagine theta is here. If theta is here, according to the earlier information, what it is sine theta. Sine theta means O by H, opposite side to the theta by hypotenuse. Now, according to the position of theta, theta opposite side is what? This is definitely hypotenuse. First, we have to identify that in a triangle. Then automatically we'll understand theta opposite side is df. So sine theta is equal to df by hypotenuse ef. According to this picture, this data, sine theta is df by ef. Okay. What about cos theta? Cos theta means a by h. Adjacent side by hypotenuse. Adjacent side by hypotenuse means to this theta, adjacent side is a de. Hypotenuse is ef. Like that, any trigonometric ratio we can write according to the data given. Okay. Suppose if we have, let us take one more example. P, Q, R. Q is 90, angle P is theta. Or let's take some other letter, not only theta, we can take even alpha also. Let's take alpha. Now, according to this, what is sine alpha? Sine alpha is fixed. O by H, that is fixed. So to the alpha, what is the opposite side? This is hypotenuse. So definitely no discussion about it. The side opposite to 90 is hypotenuse. Opposite side in the sense RQ. Whereas hypotenuse in the sense RP or PR. When it comes to cos alpha is equal to A by H, adjacent side to alpha by hypotenuse of the triangle. So adjacent side of alpha means PR is anyway hypotenuse. So adjacent side of alpha means PQ will come. So PQ by hypotenuse is fixed, PR or RP. Like that, whichever trigonometric ratio we wanted to write from the picture, we have to identify what is hypotenuse, where the angle is supposed. So according to that, we have to choose, we have to write the sine alpha, cos alpha, tan alpha, whatever they are asking, that information. Okay, right. So you are clear now about the trigonometric ratios. We took three different triangles and we have written few of the trigonometric ratios, and we understood how to write the trigonometric ratios and the corresponding sides ratio. Okay. So now, see, as we discussed earlier, if you observe these trigonometric ratios, sine theta is equal to O by H, cos theta is equal to A by H, tan theta is equal to O by A. At the same time, I wrote even the three more trigonometric ratios, which are cosecant theta is equal to H by O, secant theta is equal to H by A, means hypotenuse by adjacent side to the theta. Cot theta is equal to A by O, means adjacent side to the theta by opposite side to the theta. Right? These already I gave. If you observe a bit carefully, can we extract any relation among those? Sin theta, O by H. Cosecant theta, H by O. Means they are reciprocal to each other. Right? So that let us write. Sin theta times cosecant theta is equal to 1 because they are reciprocal to each other. Similarly, cos theta times secant theta is equal to 1. Even the same relation is happening there. And the last one is tan theta times cot theta is equal to 1. They are reciprocal to each other. Okay. So trigonometric ratios are clear. Reciprocals of the trigonometric ratios are also clear. Now, let's see some other information about this. Same triangle, basic triangle I'm taking, which I considered in the very beginning. So A, B, which is 90, C, theta. Basic information enter. Now, if angle B 90, angle C is theta, according to angle sum property of a triangle, what is the measure of angle A? We knew very well angle sum property in the sense sum of all angles is equal to 180. Out of three angles, one angle is 90. One angle is theta. Then the third angle must be 90 minus theta. Okay. Now, let's observe one thing. In this picture, sine theta is equal to, we knew very well, O by H, opposite side to the hypotenuse, which means BC by AC. What about cos 90 minus theta? When we are talking cos 90 minus theta, from 90 minus theta point of view, you have to write cos in the sense adjacent side by hypotenuse. So to the 90 minus theta, what is the adjacent side? Because according to the 90 minus theta position, you have to write the adjacent side. Earlier, based on theta point of view, we have written. Now, according to 90 minus theta point of view, we have to write. So 90 minus theta point of view, if you see, cos 90 minus theta, adjacent side is AB and hypotenuse is AC. (90 minus adjacent AB) and this is okay. Okay, earlier I made a mistake here. Sin theta is actually opposite side to the theta, means here BC not AB only will come because theta opposite is AB. By mistake I've written BC. Okay. Now if we observe AB by AC, AB by AC. Sin theta, cos 90 minus theta, both are same. You know why? Those two angles are complementary angles. When two angles are complementary to each other, we have a relation among the trigonometric ratios. Okay. What is that? Let us. See, sine A, I'm writing general form, that's why I'm using A. Sine A is equal to cos B if A plus B is equal to 90 degrees. So whenever two angles are complementary to each other, means sum of those two is 90 degrees, then automatically one side just you apply sine. Sine of it is equal to the other side cos of it. Sine A is equal to cos B. Similarly, secant A is equal to cosecant B. Same condition. If A plus B is equal to 90, then only it will happen. And the last one, tan A is equal to cot B. Same condition. If A plus B is equal to 90. So whenever two angles are complementary to each other, these are the three different conditions will appear among the trigonometric ratios. Sin A is equal to cos B, secant A is equal to cosecant B, tan A is equal to cot B. Okay. So once again, let us recollect what we discussed till now. Firstly, we discussed about trigonometric ratios, followed by reciprocals to each other, followed by complementary trigonometric ratios. We discussed about three things till now. Okay. After this, let's talk about identities. Okay. That identities are heart of the topic trigonometry that we will see. These trigonometric identities very simply will come based on the topic which is Pythagoras theorem, which we learned in grade 7 itself. Okay, let's see what is that. How we have identities in algebra, similarly we have identities even in trigonometry as well. Means which are suitable for any angles. Very rare here and there we'll find some condition, except that it is suitable for all kinds of angles. Let's take the default one, A, B, C for our convenience. I'm taking as usual theta here. Okay. Now, according to Pythagoras theorem, what can we write? AC square, which is hypotenuse, is equal to side square plus side square, in the sense AB square plus BC square. Right? Let's divide both the sides with AC square. This condition, AC square. Here also AC square. With AC square, I'm dividing both the sides, both LHS and also RHS. In LHS, AC square by AC square means I'll get 1. Whereas in RHS, if I split that AC square to both the terms, I'll get AB square by AC square plus BC square by AC square. This AB square by AC square, I can write it as AB by AC whole square. And this as BC by AC whole square, which is equal to 1. Now observe carefully from the picture, if angle C is equal to theta, then AB by AC can be replaced with the sine theta whole square, which is nothing but sine square theta. And BC by AC, BC in the sense adjacent side to theta, AC is hypotenuse. So that can be replaced with cos theta, which can be written as cos square theta. So 1, LHS 1 remains as it is. This is the first trigonometric identity. What is that? Sine square theta plus cos square theta is equal to 1. First trigonometric identity. That is true for all the values of theta. Okay, that's the reason we are calling that as an identity. First and foremost trigonometric identity, that is. And second one, let us see. Even that second one also will come from this basic condition of the Pythagoras theorem. So here, again, let's back to the Pythagoras theorem statement. Hypotenuse square is equal to side square plus side square. Then I got AC square is equal to AB square plus BC square. This time, let us divide both the sides. Earlier, we divided with AC square. Now, let's divide that with BC square. Okay. So AC square by BC square can be written as AC by BC whole square. And the other side, if I split that square, BC square to both the terms, I'll get AB square by BC square plus BC square by BC square. And this AB square by BC square can be written as AB by BC whole square. And this will become 1. This is AC by BC whole square. It remains as it is. In the next step, if I transpose this AB by BC whole square to the LHS, then this is equal to sine, means just I'm rearranging there itself, minus, and this will become 1. Now from the picture, AC by BC, AC in the sense hypotenuse to the theta, means for the triangle, BC is the adjacent. Hypotenuse by adjacent. Then that is nothing but secant theta or secant square theta minus AB by BC. AB is the opposite side. BC is the adjacent side to the theta. So then that can be replaced with the tan square theta, which is equal to 1. This is the second trigonometric identity. Secant square theta minus tan square theta is equal to 1. Okay. And the third one, last one, easy to guess. We got first trigonometric identity by dividing that Pythagorean theorem statement with AC square on both the sides. Second one we got by dividing BC square on both the sides. Can you guess how can we get the third identity? Yes, your guess is correct. We have to divide with AB square on both the sides to get the third identity. Let's do the same. So if I divide both the sides with AB square, I get like this. So AC by AB whole square is equal to, if I split this AB square to both the terms in RHS, AC by AB whole square, AC is hypotenuse, AB is opposite. Hypotenuse by opposite means cosecant. Okay, that we'll replace later. AC by AB whole square only I'm writing again. And this AB square by AB square, anyway, it will become 1. This BC square by AB square, I'm transposing to LHS. And also I'm writing that as BC by AB whole square. This AB square by AB square remains as it is in the RHS only. So this now, let's switch that to the trigonometric ratio. AC by AB. AC by AB means hypotenuse by opposite side, which means cosecant square theta. BC by AB whole square. BC means adjacent side to theta. AB is this one, opposite side, which means cot square theta. We knew well, adjacent by opposite is cot. And RHS 1, because AB square gets cancelled. This is the third trigonometric identity. Cosecant square theta minus cot square theta is equal to 1. Okay. So altogether we have three identities. Sin square theta plus cos square theta is equal to 1. Secant square theta minus cos square tan square theta is equal to 1. Cosecant square theta minus cot square theta is equal to 1. Total three identities are there. In these three identities, in higher grades, means in +1, +2, we'll come to know that there is again a little variation for first one and the next two. What is that little variation? We'll come to know that first identity is literally we can use for any angle. For any angle of theta. Theta can be replaced with any angle. It holds good. That's the reason the first identity, what I mentioned here, is also called as pure trigonometric identity or pure identity. Whereas this secant square theta minus tan square theta is equal to 1, cosecant square theta minus cot square theta is equal to 1, holds good unless some problematic value comes. What is the problematic value? See, this is only holds good if theta we can say does not belongs to or not equal to. Theta not equal to 2n plus 1 into pi by 2. What does it mean? 2n plus 1 is the general form of an odd number. So odd multiples of 90 degrees means 90 degrees, 270 degrees, 450 degrees. For these angles, theta doesn't hold that condition. Means secant square 90 minus tan square 90 is not at all equal to 1. Secant square 270 minus tan square 270 is not equal to 1. That is something else. Except the odd multiples of 90 degrees, you can take any value for theta, then it holds good. Only in that case that fails. Okay. When you are listening this, maybe you got some doubt. We are talking trigonometry about a triangle. In a triangle, maximum angle means maybe 179. If the other two angles are half and half like that, then how can we get 270 degrees, 450 degrees? You may get doubt. I told you in the beginning. Trigonometry basically started with right angle triangle. Later on, it is developed even to any kind of triangle itself. Similarly, in further grades, in the next level, that is even developed beyond 180 degrees also. Not only 180 degrees. Trigonometry even developed beyond 180 degrees theoretically. That's the reason. Theoretically, if you see, practically, maybe it is not possible. Theoretically, it is completely developed beyond 180 degrees. So there, if you see, for 90, 270, 450, like odd multiples of 90 degrees, second identity fails. Okay. Similarly, third one also, there is some condition. Even it will fail in particular values. What is that? If theta does not belongs to or doesn't not equal to, we can use anything. If theta is not equal to n pi, n means symbol of natural numbers or whole numbers. Natural numbers, let us take pi, 180 degrees. Means if the angle is a multiple of 180, in that case, third identity fails. Rest of the cases, perfect. It holds good. So suppose if theta is 180, cosecant square 180 degrees minus cot square 180 degrees is not equal to 1. Cosecant square 0 degrees minus cot square 0 degrees is not equal to 1. Like that, multiples of 180. Multiples of 180 means you can take 0 into 180, 180 degrees, 0 degrees, 0 into 180, 180 degrees. Like that, multiples of 180, if you take theta, it fails. Except that any value of theta, it holds good. Means second identity and third identities are having some conditions. Such kind of conditions are not there for the first one. So that is called pure identity. Whereas the second and third are said to be conditional identities. Only in those places it they fails. Remaining all the places fine, well and good. Conditional identities. Okay. So if you just recollect what we discussed till now, again I'm just giving a reminder to you. Trigonometric ratios, followed by reciprocals, followed by complementary trigonometric ratios, followed by trigonometric identities. Even I discussed the proofs also for that. Sometimes, very rarely, they'll ask even proofs also in the examination, board exams. Very rare. Many of the cases, just we use only the identities to solve the problems. Okay. Hope you understood this concept till now. Just I wanted to discuss till here only in this session. Okay. I hope you understood very clearly concept of trigonometry, which we discussed in this session. Right? That's the end of the session. Thank you very much.